Hi, this is Alex from devstories.eu. LangGraph, episode 14 of 18. Users hate staring at a static loading spinner for 30 seconds while your system works behind the scenes. You want to show them the system's thought process in real time, but capturing those internal signals often requires wiring up complex custom callbacks. Streaming execution and the V2 format solve this by unifying every internal event into a single, predictable flow. First, clear up a common misunderstanding. Engineers often confuse streaming language model tokens with streaming application state. They are entirely different layers of information. A token stream is just text appearing word by word. A state stream tracks the broader progress of your workflow moving from one task to the next. LangGraph handles both simultaneously. You access this behavior by requesting a stream and passing the argument version v2 to your execution method. This standardizes the output. Instead of dealing with mixed data types, every single event that leaves your graph becomes a unified dictionary containing exactly 3 fields: type, NS, and data. The type field defines the category of the event. The NS field stands for namespace, indicating the exact path in your graph hierarchy where the event originated. This becomes critical when you have nested subgraphs and need to know exactly which subcomponent fired the event. Finally, the data field holds the actual payload. You control exactly what gets put into this stream by selecting one or more stream modes. The values mode pushes the complete updated graph state to you every time any node completes its work. This proves useful if your application requires the full picture at every step. The updates mode is much lighter. It streams only the specific data returned by a node, representing just the delta or change made to the overall state. The messages mode operates at a more granular level, streaming the individual chunks of a generated chat message as they are produced by an underlying language model. Picture a front-end interface. You want a glowing status indicator that highlights which step is currently active, perhaps fetching context, then evaluating documents, then drafting, while simultaneously displaying the draft text token by token. To build this, you start your graph execution with stream modes set to both updates and messages, ensuring you pass the v2 version flag. Your front end begins receiving a continuous, unified stream of these dictionaries. When a dictionary arrives with the type set to updates, you read the namespace field. This tells you exactly which node just finished its work. You use that signal to shift your glowing status indicator to the next step on the user interface. Milliseconds later, the stream delivers a new dictionary with the type set to messages. You pull the raw text token from the data field and append it directly to the paragraph your user is reading. Both high-level state changes and low-level text generation arrive through the exact same pipe. Here is the key insight. By forcing tokens, state changes, and node progress into a single 3-field dictionary structure, the V2 format completely removes the need to write separate handling logic or complex asynchronous callbacks for different types of real-time events. That is your lot for this one. Catch you next time.